This video will give you questions 23 through 28. And notice here in the lower right corner I have the correlation to the actual question numbers from Science Geeks, where they have the release questions in the same order that they come in from the state of California. So look to here to see the question number, and don't use the guy that's up there in the top left corner. This 3 up here really is 23. Okay, so here you can see there's lots of things that you need to know for being ready for the CST. You need to know what an alpha particle is, you need to know what electrons are, and gamma radiation. So that's all described for you here, and the answer to this one is letter D, alpha particle. And let's move on. Question number 4, your answer is C, and your reasons, of course, are over here. And as you go to number 25, you see here the reasons, and here is your answer, letter D. Going to 26, you see this is number 26, the explanations, and you also have. This video will give you your answers to questions number 23 up to 28. And you can see the question numbers down here, and you do not want to use the number up here. This number 3 is the number in my file, not the number on the Science Geeks. So always be sure to check your number out down in the lower right corner here. And here on this question you can see the things that you need to know based on the answers that you see. You know that each one of those is going to be questioned in, or possibly questioned on the CST that you actually take. So you'll need to know about alpha particles and beta particles. These two guys are actually particles. This is pure radiation, as is the X-rays. So your most dangerous is gamma, because it can go through anything. X-rays will not go through lead, and so we can protect places where we take X-rays. I'm giving you this orally because I didn't get it into the stuff over here. But X-rays, all of this stuff though is at the end of chapter 4, and you can get good explanations there as well to get your page numbers. Alright, here we go with question number 24. Oh, back here on question number 3, your answer is letter D. And back here now for question number 24, this guy, the answer is C. And remember your no on 17. That's nitrogen, oxygen, and hydrogen. Oops, didn't put the hydrogen in. So yes, now we're fixed. Nitrogen, oxygen, and hydrogen, and all elements in column 17. Diatomic unless specified otherwise. Your answer here on number 4 is letter C. Let's go to number 5. The answer is D, and you need to know about cations and anions. As charged particles, they usually form ionic compounds when they are mixed together. And so this guy, when the cations and anions join, they're saying they form what kind of compound? Of course it has to be ionic. And remember, you need to know about covalent, metallic, and hydrogen bonding as well. So you can look in the chapter on chemical bonding, and that will give you that stuff. And so that's number 25. Number 26, your answer is D, like David. And letter B cannot work. This guy is a no-no, simply because carbon has to have at least 4 bonds. These two guys don't form ions as such, because they are not a metal with a nonmetal, and so they couldn't be written as ions. And if they were, you wouldn't have enough hydrogens. Just like here, you have to have 4 hydrogens on this guy, or at least 3 other elements bonded to it, and they would all have to be nonmetals. And you certainly can't write it this way. So This is your only choice down here, letter D. So again, your answer here is D. And let's go on. And that was 26. 27, you've got no nonmetals in any of these guys here. Okay, so nuclear bonds exist among particles in the nucleus, and so you can rule that out. And covalent bonds are always between two nonmetals, which is what we have here. And that's why your answer is C. Going on, number 8, your common molecules here. You're asked to choose among polar, covalent, ionic, and metallic. Okay, and what type of bond do all of these guys have? So all of these guys have, excuse me, covalent. There's actually a polar covalent in ammonia and methane, and you can see why as you look at the Lewis structures over here of these two guys. But because they are symmetrical, they are not polar molecules either. Well, this guy is a polar molecule, but his bonds are absolutely covalent, but they're actually polar covalent bonds. So the polar covalent is a type of covalent. Anyway, number 28, or that's question number 28, and that's the end of this one.